Okay, so as you can remember, on our previous lesson, we have learned kinematics. Kinematics in kinematics, in this part of mechanics, mechanical motion is considered without any factors or reasons that may affect this motion. And now we are going to start learning dynamics. In dynamics, we will take into account some factors that may have influence on mechanical motion. And it is known that the main laws of dynamics are Newton's law of motion. These laws of motion are a result of many experiments, many observations, and the first Newton's law of motion. I think I will type this. I will type this. Newton's first law of motion. Sorry, Newton's first law of motion. Newton's first law of motion. And according to this law, every body continues in its state of rest. Yes, on its state of rest, or of uniform motion. Uniform motion in a straight line. In a straight line. Unless it is compelled to change that state by forces impressed upon it. Forces impressed upon it. So this is Newton's first law of motion, and I will frame this with red. Because it is a very important physical law. So according to this, every body continues in its state of rest or of uniform motion in a straight line, unless it is compelled to change that state by forces impressed upon it. impressed upon it. So this is the formulation of this law. And reference system in which this law of motion occurs is known as inertial system. In other words, inertial system is a reference system where Newton's first law is true. Or what? Which system can be used as inertial? For example, in very many cases, the system that is connected to the sun may be considered as inertial, system. But in many cases, for many systems on our planet, the system connected to the Earth may be considered as inertial. Okay, so in which case state of rest or uniform motion can be changed. How to change? In other words, how to change the velocity, or the direction of the motion. How to change this? The first, what is necessary to say, we need to define a new physical value, that is known as momentum. What is momentum? I will type this. Momentum is a physical value that is a product of mass and velocity. So m is mass. M is mass. We have defined a new physical value, momentum, and a new physical value, mass. New physical value that is mass. So what is mass? According to observations and experiment, and according to our experience, from the last 3 centuries, we can say that the mass is the bigger mass is, the more difficult to change the velocity of the body. So we can write acceleration of the first body divided by acceleration of second body is equal to mass of second body and mass of first body. So we have here inverse proportion. It means that the velocity of heavier body is more difficult to be changed. is more difficult to change than the velocity of body with less mass. And as we can know from experiment, and after defining these values, we can define Newton's second law of motion. Newton's second law of motion. So I will type this again. I will type this. Newton's second law of motion. Newton's second law of motion Newton's second law of motion. And according to this law, the change of momentum, the momentum was defined previously. The change of momentum of an object change of momentum of an object is proportional to the force impressed and is made in the in the direction of the straight line in which the force is impressed. In which the force is impressed. So what does it mean? It means that we can write a formula, that the first derivative of momentum is equal to the force. And what is force? Force is a measure of the interaction between different parts of material system. Measure of interaction of different parts of material system, and the larger force is, the more intensive interaction is. So we can write this with this formula, or we can use another formula, or we can write this formula in another way by using this equation. So we can make substitution. And As a result, we will obtain that first derivative by dt is equal mv, the product of mass and velocity, or mass multiplied by velocity, is equal to the force, or the sum of forces, vector sum of forces. And if we can say, if m is equal to const, if m is equal to const, we can write that m first derivative of v by time is equal to the force. And from our previous lesson, we can remember. I hope that we can remember that this derivative of velocity with time, change of velocity with time, is equal to acceleration. This is acceleration. So according to this, we can write that we can write another way, another form of this equation. Mass multiplied by acceleration is equal to the force. I think this formula you may know from school. You may remember from school, or this can be written in one more way. As you can remember, acceleration is also equal to the second derivative of radius vector. Second derivative. So this is second derivative. So we can write one more formula. Another formula that m second derivative and this is equal to f, and this is equal to f. So this is Newton's second law of motion, and we can also rewrite this law for coordinates of vectors, but I hope that this is clear. That you know this. And you know this. And okay, do you have any questions? Do you have any questions about this first and second laws of motion? No questions. No questions. Okay. Okay. If there is no questions, it is necessary. It is necessary to have a look at some different types of forces. So the first force is elastic force. What is it? What is it? Let's consider such a system. Consider such system. This is fixed wall, and this is connected. This is connected to the spring. This is connected to the spring, and let's imagine that we have made some elongation or extension of its length, some extension or elongation, and this elongation is equal to x. Or okay, let's left this let's leave this as x. Left this as x. X is extension. X is extension, and in this case, the elastic force will occur in this system, and this will be direction. Controversially according to the extension. The direction will be opposal to the extension. So we have elastic force. Elastic force, and according to the Hooke's law, in many cases, we can write Hooke's law. In Hooke's law, according to the Hooke's law, elastic force is equal to the minus kx. Minus kx, where f, I will write this, f is elastic f is elastic force x is extension or elongation. This is the same. And key or k is spring constant. Spring constant is spring constant. K is a spring constant. K is a spring constant. Okay, so do you have any questions? Do you have any questions about this? About Hooke's law? Okay, it is necessary to say that often Hooke's law is written in another form. So let's have a look. Let's have a look at homogeneous rod that has a form of cylinder or cylinder of some. Okay, let's consider this as a cylinder. So it has initial lengths. It has initial lengths of L. In case when it is when its form isn't changed, it has length L. And let's make some extension. And but now we will sign this as delta L. So delta L is the same as x. So I can write here or x or delta L x or delta L is extension or elongation and for this rod, for this cylindrical rod, Hooke's law can also be used. So we can write Hooke's law in this way: K delta L. And in this case, I will use absolute value. And it can be written as K L delta L divided by L. And this can be written. We can divide left and right parts of the equation by square of cross section S, square of cross section of this cylinder, and this will be key L divided by S delta L divided by L. Absolute value. Okay, so do you have any questions about this? No questions. Okay, that's great. That's great. So according to this, as a result of this, we can write another form of Hooke's law. Another form of Hooke's law. Another form of Hooke's law. So or it means or sigma is equal to the E multiplied by epsilon. Now I will explain. What does it mean? Sigma. Sigma is equal to F divided by S. Divided by S. So this is so-called tensile strength. Is tensile strength. Tensile stress. Tensile stress. Or it can or mechanical tension, tensile stress. So this is a result of our transformations that have been made. So what is E? What is E? E is equal. In this case, it is equal to K L divided by S. Is Young modulus. Is Young modulus. Is Young modulus is Young modulus. This is Young modulus, or it is better to write in this way: Young's modulus, and the last value is epsilon. Epsilon is equal to elongation divided by initial length, and this is relative elongation or relative extension, So this is elastic force that can be defined by Hooke's law. Can be defined by Hooke's law. Okay, so do you have any questions? No questions. No questions. Okay, if there are no questions, so I will frame this in red. I'll frame this in red because this is also important. And the next force to be learned is gravity force. Or force of gravity. and it can be defined according to Newton's law. Newton's law of Newton's law of universal gravitations of universal Newton's law of universal gravitation. Universal gravitation. Newton's law of universal gravitation. According to this law, force of gravity. This is a force of gravitational attraction between two material points with masses m1 and m2. This is a force of gravitational attraction between masses m1 and m2. It is equal to G m1 m2 divided by r to the power of 2. And what does it mean? G is equal to I will type this 6 the multiplied by 10 to the power of minus 11 and here we have Newton's meters and divided by kilograms to the power of 2. So this is gravity constant. This is a gravity constant, gravitational constant. Is gravitational constant. Is gravitational constant. This is gravitational constant. Okay, do you have any questions about this? Where n is Newton. Newton is a unit to measure a force. M is meter, and kilogram is measure of mass. Unit to measure mass. Kilogram or kilo. Kilo. Okay, so let's calculate a gravity force near the surface of the Earth. Earth is our planet. Let's calculate the force of gravity. It is equal to, according to the Newton's law of universal gravitation, it is equal to G m, this is mass of our planet Earth. R is radius of the Earth, and we can find in the internet in the internet that m mass of our planet is equal to 5.97 multiplied by 10 to the power of 24 kilograms, and r. I will sign this with e, with lower index e, and this is the radius of our planet. It is equal to 6.3713 multiplied by 10 to the power of 6 meters. The power of 6 meters. So these values can be found in the internet, and we can write from here that this is equal to mg, where g is equal to g m me, mass of our planet Earth, and divided by radius of the Earth to the power of 2. And this is a well-known value that is approximately equal to 9.81 meters divided by seconds to the power of 2. So this is this acceleration of free fall. Acceleration of free fall. Acceleration of free fall. Acceleration of free fall. Yeah, acceleration of free fall. So if we know this, it lets us to find gravity force. So it is necessary to simple write F is equal to mass multiplied by the acceleration of free fall, and the acceleration of free fall is already known. And we can also use the second Newton's second law of motion. According to this, mass multiplied by acceleration, it is equal to force F. Now I have written this for scalar values, for absolute values of the vectors, and from this we can write that this is equal to mg, and from here we can obtain that for any body near the Earth's surface, the acceleration will be equal to acceleration of free fall. In the case where of how to say this, where the opposition of air is not essential. When a resistance of air is not essential. In this case, we can write that acceleration of fall will be equal to acceleration of free fall. Okay, so what can you do you have any questions about this? Do you have any more questions about this? No questions. Okay. Okay. That's great. So let's learn another important force. Another important force that is known as force of friction. Force of friction. I will write this force of friction. Force of friction, and let's have a look at such system. This is some rough surface. This is some rough surface. Rough surface, and body. Body upon it. This is a body upon it. And let's consider different forces that are impressed upon this body. The first force is force of gravity. Force of gravity. Force of gravity. This is equal to mg, mass multiplied by acceleration of free fall. This is mg. But as we know, the body that lies on rough surface, it doesn't fall. It doesn't fall, and it means that there is another force. There is another force that prevents it from its fall. That prevents it from fall. And what is this force? This force is elastic force. This force is elastic force, and it can be written. It can be written like this. It can be written like this. Can be written like this, and I will sign this with n vector. N vector. Okay, so let's also consider that that this body is in is in horizontal motion. Is in horizontal motion with some velocity v. This velocity will not be a constant. Will not be a constant because we have force of friction. We have force of friction. Even in a case of a very smooth surface, even in this case, we have little, but we have this. We have a force of friction. Force of friction. and it acts in this direction, that is opposed to the direction of the velocity, force of friction. Force of friction. Force of friction. And according to this picture, and according to Coulomb's law of friction, Coulomb's law of friction, it can be written as F without it. I will write this as a scalar value, and it can be written as mu absolute value of n, and where mu is friction constant, where mu is friction constant, mu is friction constant or friction coefficient, is friction constant or coefficient coefficient of friction. Friction constant or coefficient of friction. So this is mu. This is mu. In this case, mu. Greek letter mu. So this is force of friction. Force of friction. Yes, force of friction. Okay. Do you have any questions? No questions. No questions. Okay, so I think it is possible now. It is possible to clean some place on the screen. I hope it is clear. I hope it is clear, and I hope tomorrow we will use some of these theories that we have learned, and as I can write, let's consider a material system that consists of two material points. Material system that contains two material points. The momentum of this system is equal to the sum of momentums of two material points in this system. And let's consider that there are no any external forces impressed to this system. There are no any external forces. In this case, according to the first law of motion, this will be equal to the to some constant. Will be equal to some constant. If there are no any external forces. Okay, so what does it mean? What does it mean? It means that first derivative. It means that first derivative. It means that first derivative is equal to first derivative of this. First derivative of this plus first derivative of the momentum of the second material point. And this is equal to 0. This is equal to 0. So as I have said that there are no any external forces, but there may be some internal forces. Internal forces are forces between different parts of material system. So according to the second law of motion, we can write that this is equal to F, and this is equal to F21. F21. The F12, this force, is a force that impressed on first material point, and this is a result of interaction between material points. And the F21 is force impressed, internal force impressed upon the second material point. And from here we have the equation. According to this, F12 plus F21 is equal to 0. And according to this, we can write that F12 is equal to minus F21. Okay, and according to the many experience, and according to many experiments, and according to experience of humanity, this equation can be generalized. As for any two material points, internal forces Fi key is equal to minus F key I for any two material points. And this is known as Newton's third law of motion. Okay, let's write this. I will clean my screen, and Newton's third law of motion. Newton's third law of motion. Newton's third law of motion. According to this law, to every action to every action, to every action, to every action, there is there is always opposed or opposed and equal. There is always opposed and equal reaction. Opposed or equal reaction. Or the mutual actions of two bodies upon each other are always equal and directed to contrary paths. And directed to contrary paths. So this is Newton's third law of motion. Newton's third law of motion. And in a short way, it can be written as with this equation. So we have such formula. Okay. Do you have any questions about this? Do you have any questions? No questions. Okay, so let's continue. Let's continue in this case. Let's continue. Let's continue. Let's have a look at second law of motion more particularly. According to this law, we can write that derivative of momentum is equal to F where F is vector sum of all forces impressed on our material system. So we can write this sum of I is equal to 1 n n may also be equal to infinity and may be maybe finite number or infinity. So and here we have key is equal to 1 n, but key cannot be equal to I. And according to this, here we have F key I vector and plus the sum of plus the sum of n is equal to n is equal to 1, f n. Here, this is sum of all internal forces, and here we have sum of external forces. Sum of external forces. But according to the third law of motion, we have that first sum is equal to 0. And from this, from second and the third laws of motion, we have that change of momentum in time. That is defined by first derivative, is always equal to vector sum of external forces. So we can write that more particular has more particular form of second law of motion. Okay, do you have any questions? About this? Do you have any questions? No questions. Okay, that's great. I hope that everything is clear. So we have what do we have here? From here we can make a conclusion that if I'll write this, if the sum of external forces, if this sum is equal to 0, if this is equal to 0, we have that first derivative is equal to 0, and it means that P is equal to, for example, but I think I will write this just like n. That sum of momentums of all material points, and this is equal to, as you can remember, momentum is a product of mass and velocity, and this is equal to mi vi. So we have obtained the law of conservation of momentum. Law of conservation of momentum. Law of conservation. Law of conservation of momentum. Law of conservation of momentum. According to this law, if the sum of external forces is constant, the sum of momentums will be if the sum of external forces is equal to 0, the sum of momentums will be constant. Will be constant, but I haven't write this. I haven't tried this, but it is necessary to do. This is equal to const. Equal to const. This is very important. This is equal to const. Law of conservation of momentum. Okay, so do you have any questions about this? No questions. No questions. Okay, that's great. That's great. And the last thing for today to learn is the center of mass. The center of mass. According to the definition, the radius vector of center of mass can be written by this formula. So the radius vector of the center of mass. Radius vector of the center of mass. According to this, RC is equal to sum I M I R I, where Mi is the mass of some material point, and this is divided by M, where M upper M is a mass of the whole material system. And so I can write that M is equal to sum of masses of all material points. So this is the radius vector of the center of mass. Or this can be written for solid body or rigid, or for rigid body. Rigid body consists of infinite number of material points. So for solid body, this formula must be written within integral. So I can write this. It will be triple integral R. Rho is the density. Rho is density. dV and divided by M. And where M is equal to similar integral. I hope you can remember. Such integrals from your calculus course. This formula, may let us to calculate the radius vector of center of mass. Okay, so do you have any questions? But it is very good that in many useful practical cases we don't need to use this formula. For example, if we have homogeneous cylinder, for example, it has symmetry. It has axis of symmetry, and it may be proved that if system has the axis of symmetry, the center of mass will be on this axis. And it can also be proved that if we have plane of symmetry, what the center of mass will be on this plane. So the plane of symmetry of homogeneous cylinder is here. So the center of mass is here. In this center of this cylinder. It will be the center of mass. And why do we need center of mass? Why do we need this? Why do we need this? We need this because what's wrong with this? Okay, I have some bug with my screen, but I hope it will not prevent us from our learning. Okay, one more thing. Let's use this formula. Let's transform this. Let's write this like to this form. M multiplied by radius vector of the center of mass is equal to the sum of I M I R I R I. We can calculate first derivatives of left and right parts. d by dt m r c, and this is equal to d by dt of this sum. But if mass is constant, and we know that dr derivative of radius vector is the same as velocity. So from here we have that this is equal to m, the velocity of center of mass, and this is equal to sum of m I v I, but this product of mass and velocity is equal to momentum. And this means that we can write that this is a sum of momentums, and this is equal to the whole momentum of the material system P. Okay, let's calculate. Let's calculate another second derivative. It will be equal to m. Will be equal to m derivative of velocity of center of mass, and this will be equal. This will be equal. Will be equal to derivative of momentum of the whole system. But according to the second law of motion, we have that derivative of momentum is equal to the sum of forces. This is I will show this in more proper way. I'll put this here. I'll put this here to make it clear. And from here we can see that this is equal to the sum of all internal external forces. Sum of external forces. Sum of external forces. And we have obtained this theorem, the theorem of motion of center of mass. The theorem of the center or of motion of center of mass. So according to this theorem, if we need to learn the motion of whole material system, we need to find its center of mass, and its motion can be considered as motion of one material point with mass that is equal to mass of material system. Okay, do you have any questions about this? No questions. Okay, if there are no questions, I think that's all for today. And I hope to meet you tomorrow. Tomorrow we will try to do some exercises. And use this theory. Okay, so thank you for your attention.